Hello, this video is going to cover pointers. In order for it to make the most sense, you will want to have already seen Daniel Warren's video, which covered objects and classes. We will be using the same source code that he ended with. This is house.cpp, which contains the definitions of some functions, as well as house.h, which contains some variable declarations, as well as the declarations of the functions in house.cpp. We will also be using main.cpp to write all of our code. Before we begin, what is a pointer? The easiest explanation of this is that a pointer is simply an address to some data. And pointers are really powerful. They allow you to accomplish a whole lot in programs. With the introduction to the concept of pointers, we are now able to use two new operators. This is the Ampersand Operator, which allows us to get the address of some data in memory, as well as the asterisk operator, which allows us to dereference an address in memory. And when we say dereference, this means we are actually reading the data that is stored at the address on, say, a hard drive. Let's get into some examples. Normally, when we create a variable, we do so like such. We'll have an int var, and we'll say that it's equal to 56. When we print it out, we expect for it to be 56, but we already knew this. What we're interested in is using the new operators that we were just given. So we'll start with the ampersand, which should allow us to see the address of var. So now when we run this, we'll get the value of var, which is 56, and then the value of the address of var, which we don't know what that will be exactly. So let's run it. And as you can see, we got the 56 that we expected, followed by this hexadecimal number. One funny thing about pointers is that the pointer to a variable, even if the variable is the same value each time, isn't necessarily going to provide us with the same address each time we run the program. So if we run this program again, we can see that the new address is different from the old address. This is expected, though. Now that we've used the ampersand operator, we can also use the asterisk operator to dereference the address. This would look like such. Using the ampersand already, we'll put the asterisk in front of it, and now what we expect is that var will be printed out first, followed by a space, followed by the value of var again. So we should see 256s. And as you can see, we do. Now pointers can be variables. You can have a variable that is a pointer to another variable. I'll show you what this looks like. If we wanted to have a pointer to var, we would say that we have an int pointer using int followed by the asterisk, and then the name of our variable. We'll call it pvar for pointer to var, and then we can set it to the address of var, because remember, pointers are just addresses. If we wanted to see whether this is the same address as the address of var, we can also compare that by printing them out. Let's do that. And when we run it, while we are getting a different address each time we run it, we can see that the address of var is equal to the value of pvar. You can also dereference pvar to get the value at the address that is the value of pvar. So this is, we can dereference pvar to get the value of var. Let's do that. We should expect it to be the same as var. And as you can see, 56, the address of var, and then 56. Another cool thing about pointers is since they are pointing to the address of some other data, if you modify the value at that address, it will also modify the dereferenced pointer. This is to say, if we were to change the value of var from 56 to, say, 9, when we dereference the pointer to var, that is pvar, we expect it to print out 9 as well as var to print out 9. Let's do that. This is what we expected. Using these concepts, we can then start using our house source code. So let's delete this. At the top of our code, we will include house.h, and now let's start writing, now let's start initializing our house. So we'll have this house named h. We're going to set the number of beds to 3. This is a standard house after all. And then we're going to set the number of and then we're going to set the number of beds to 3 as well. And of course, we're going to use the set functions rather than the get functions. We'll also set the street. We'll call this, we'll say that this house is located on University Street. We'll also print out these values once we have run them, just to prove that they are what we expect them to be. And to make this more human readable, we'll say baths. We'll say beds. And street. Followed by, as always, an mline. Now when we run this, we should have our house with 3 baths, 3 beds, and the street should be University. We have 3 baths, 3 beds, and the street is University. So now let's write a function that modifies our house. We're going to create a function that actually upgrades our house. We want to double the house's size. So we'll do upgrade house. We'll have it take a house in as an argument. And what it does is it doubles the number of beds and the number of baths. So we'll have our new baths is equal to h dot get number of baths times 2, and new beds will equal h dot get number of beds times 2, and then we will set the house's baths to new baths. Oh. And we'll set the number of beds to new beds. We'll just make sure that I didn't forget a semicolon here. Okay, now let's call it. We'll pass in h, which is the house that we created, and now we'll run it. That's not right. So it looks like when we passed in h, and then we told it to upgrade the house, we didn't actually upgrade it. We ended up with 3 beds and 3 baths. We can fix this, though. Rather than saying that it is void, we will say that it returns a house, and then we'll return h out here. And we'll set h equal to the return value of upgrade house. Now let's run it. There we go. We can see that the number of beds has doubled and the number of baths has doubled. This seems a little bit complex, though. Why should we have to set h equal to itself again after we call upgrade? We can do better. And the way we can do that is by passing a pointer to h in upgrade house. So let's do that. We'll set our function back to void. Now we'll pass a pointer to h. A pointer to h. Sometimes it can be a little bit confusing which operator you need to use. And now you can see that we have these errors. That is, this expression class must have a type. This is, well, usually when we have a house, we have that direct object. But now we have a pointer to that object. And normally we would dereference the pointer using the asterisk. But that doesn't work here, because that actually says, well, this whole value is now a pointer. We don't want that. We only want h to be a pointer. So we'll cast it with some parentheses. Now we are dereferencing h. Now we have a house object, and we're getting the number of baths for that. Once again, though, we can do better, because it can be rather draining having to type out the asterisk and type out the parentheses and type out the dot each time you want to dereference a pointer and then use a pointer to an object and then use a function on that object. Luckily, C++ provides us with a shortcut to get around this, and this is the arrow operator. If we have a pointer to an object, we can use the arrow operator to dereference that object and call the method from that object, which is the same as using the parentheses and the asterisk and the dot that I had already done. So let's go through and set all of these to arrows. And since we are void, we will no longer return. With this, we should now get the same result as the last time we ran it, where our house has doubled. Let's run it. As you can see, this is the case. And this is good because we used less code to do the thing that we wanted to do, and it's more understandable. When you upgrade a house, you don't expect to get another house from that. You expect for the house that you pass in to be upgraded. At this point, we've covered the fundamentals of pointers. There are still other concepts that could be covered, such as using the new keyword when constructing objects, as well as the delete keyword when destructing them, but understanding what pointers are is more important.